Okay, so hello everyone, welcome back. I guess we can start now. Sorry for this small delay, so we had some technical difficulties, and right now we'll just proceed with our webinar, which is also going to be recorded and later available in our social media. So today's topic is OpenShift Container Platform, and with me it's Jarosław from Red Hat. So if you could briefly introduce yourself.
Sure. Hi guys, my name is Jarek. I work as a solution architect for Red Hat. I'm focusing mostly on application platforms, which includes OpenShift and Red Hat JBoss middleware portfolio.
Okay, and a few words about me. So my name is Marcin Kubacki. I'm Chief Software Architect at Storware, and my main experience is basically infrastructure virtualization. Now also I'm going to gain some insights into the containers world as well. So maybe let's start with a small brief introduction to containers.
Sure. So today we're gonna talk about OpenShift from the operators and administrators point of view. So the first thing I would like to emphasize here is that the containers when you start a container, it really means that you are running a process on the Linux operating system. So the security, performance, reliability of your running container is really all about the quality of the Linux operating system that you are running. And that's why the foundation for OpenShift is, of course, the Red Hat Enterprise Linux operating system.
Okay, so between basic container and running real-life deployments, I guess there is a huge difference. So maybe let's talk about how to get there.
Yeah, sure. So operating system is a foundation. So as I said, we run containers in operating system, but if we want to orchestrate them, if we want to run containers on a large scale, we need the container orchestrator. And those days, most likely, if you will start searching for a container orchestrator, you will find Kubernetes, which is a leading containers orchestrating platform available. But again, Kubernetes is again just a software. So in order to let Kubernetes orchestrate your containers, you need not only the operating system where your containers will run, but also you will need a networking where the pods or containers will be connected each other. You might need the storage if you will run some stateful applications that requires to persist some data. On the other hand, Kubernetes also do not deliver too many user-friendly tools. So you have the command line, you have some basic web console, but really for operators, for administrators, you need some more sophisticated tools to be able to aggregate logs, to monitor the platform, the applications. Also, developers will need some tools to build images, to implement the CI/CD processes, to run the containers. Also, we cannot forget that Kubernetes is released more or less every 3 months. So you need also a good tool for installing, upgrading your Kubernetes environments. And also, last but not least, we cannot forget that the security is also a big concern in containers environments, and really here security in the platform means that you really need to secure all the layers that of your container platform.
Okay, so I understand that Kubernetes is the core of the solution. So, but what is actually delivered with the OpenShift on top of regular Kubernetes installation? So,
yeah. So if we look on this picture, it can be translated into the OpenShift container platform architecture. So on the bottom we have the Linux operating system and the Kubernetes. Then we have the core infrastructure components which are needed to run Kubernetes. So the networking, storage if you have stateful services, tools for monitoring, for log aggregation, and then on top you see a lot of additional tools which can be used by developers, by application architects to implement different types of application architectures to build cloud native applications and to develop them efficiently. And then last but not least, on the top you can see that there is a new layer for multi-cluster management which you can use to centralize the management of your multi-cluster OpenShift environments.
Okay, so and what if I would like to customize or extend OpenShift somehow?
Yeah, so you can see there is a lot of tools, a lot of components in OpenShift, but still there's even more tools that you can use to customize the platform. And this is one of the reasons why we decided to emphasize in OpenShift 4 the concept of operators. So with operators you can build dedicated software that will be deployed to OpenShift or to Kubernetes and will be able to deploy your specific applications. So all OpenShift components are driven by operators. So when you want to install one of the OpenShift modules, there will be some operator that you will install, and furthermore this operator will install the software you want to use. Also, all the core OpenShift components are operators driven. So when you install OpenShift, you will install a bunch of operators. And also the ISVs or some open source communities can build their own operators in order to be able to deploy the applications in OpenShift.
Oh, okay. So, and how to use such operator?
Yeah, so if we look under the hood of the operator, it's basically quite simple. So what you will really get, you will get a pod which is deployed using some deployment. So the operator developer will prepare for you a container and a deployment that you can easily deploy it to OpenShift. And also the operator will define one or more custom resource definitions. So these are the YAML files, which allows you to configure the software that the specific operator is providing. So here you can see on the right hand side a simple example of a CRD file that is delivered by OpenShift logging operator. So when you create this file, you can specify what should be what components of OpenShift logging infrastructure should be installed in your environment, and you can specify some parameters for those components. And when you will create such a file in your OpenShift cluster, the operator will automatically pick up this configuration file and will execute the process of the installing the log aggregation functionality. Also, if you will make some modification to the file, it will be again picked up automatically by the operator and will execute the redeployment of your existing logging infrastructure.
Okay, but still, I guess it's some work needs to be done. So maybe somebody has already done it, and we can use it ready.
Exactly. Yeah. So we cooperate with the ISVs, with some open source communities, and we have created the kind of marketplace for operators, which is called Operator Hub. So you can visit the operatorhub.io webpage, where you can find over 100 different operators delivered by ISV partners, by communities, also by Red Hat. And you can use this hub as a source for operators that you can install on your OpenShift clusters based on your specific needs or requirements.
Well, okay, so we have talked about slightly a bit operators. Now, maybe if you could describe OpenShift architecture a bit more in detail.
Sure. So OpenShift architecture is really based on the Kubernetes architecture. So when you install OpenShift cluster, it will consist of multiple physical or virtual nodes or servers. Those servers needs to be connected with one network. So all the nodes needs to be able to communicate via TCP/IP. And also, optionally, if you will deploy some stateful workloads, you will need some storage to be also available for the cluster. So when you will install the cluster, there will be two types of machines. So the first one are master nodes. And master nodes, they are the control plane for your cluster. So this is where the core Kubernetes services will be deployed, the etcd database, which holds the cluster configuration, and also some additional OpenShift specific services that extend the core Kubernetes functionality. Then the second type of the machines in the cluster are worker nodes. On worker nodes, you will deploy either your own containerized applications. So this is where you will execute your own pods. But also there are a number of OpenShift so-called infrastructure components, which provide some operational or management functionalities for OpenShift clusters. So you can see here 4 of those components mentioned. So the monitoring stack based on the Prometheus Grafana Alert Manager, the routing layer, so the out-of-the-box implementation of Kubernetes ingress functionality in OpenShift, container images registry, which you can use as a kind of local cache for storing the images that are used to run containers in the cluster, and the log aggregation stack, so Kibana, Elasticsearch, and Fluentd. This is the kind of logical architecture of the cluster, and it might be translated into a physical architecture where you will install the master node. So for fully highly available configuration, you will need odd number of masters. So typically 3 master nodes are good fit, and we encourage to deploy only 3 masters in OpenShift cluster. Then you have a bunch of different worker nodes. Some of them are general purpose nodes, worker nodes where you can deploy your own applications. So those purple ones in the middle. You can also have a dedicated worker nodes called infra nodes, where you can install and deploy the OpenShift infrastructure components. So those 4 I mentioned before, but also some other. And then there is also an option for OpenShift to install dedicated nodes for where you can deploy container storage based on the Ceph technology, which I will talk more about later on.
Okay, but well, at this point, well, what are the options that how we can install OpenShift?
So in general, you have two options. Either you will use OpenShift as a managed service. So currently, the 4 biggest public clouds offering, so AWS, Azure, Microsoft Azure, Google Cloud, and IBM Cloud, offer the managed OpenShift as a managed service. So you might choose that option, and when you choose that option, there is no need from you to install and maintain the OpenShift cluster. It is maintained by the provider, so either Red Hat or the cloud provider themselves. And also always you have an option to install OpenShift yourself. To get the OpenShift installer and to install OpenShift either on premise in your own data center, on physical or virtual machines, or you can also buy some machines or some infrastructure from the public cloud vendor and deploy your cluster on those machines.
Okay, so let's focus on this on-prem in that case. So how do I install it on-prem?
Yeah, so for the on-prem and for the custom installations, you have two options. So the first option is called installer provisioned infrastructure installation, and this is where you will use OpenShift installer to deploy not only the OpenShift cluster itself, but also the all infrastructure that is needed to run your cluster. So you can see here on the picture that in this mode, installer will deploy first will deploy the nodes, so the control plane, so the master nodes, the worker nodes, and then we'll deploy the OpenShift on top of them. Everything within one highly automated installation process. So the great benefit of this approach is that really from the user point of view, the installation is very simple, automated, but also there is a downside that you have very small or even none way to customize the infrastructure that where you want to deploy OpenShift. And in order to meet that requirement, there is a second option to run an installer called user provisioned infrastructure installation, where as you can see, before you will be able to install OpenShift, you will have to prepare the infrastructure, so the servers, the networking, and only after you prepare the infrastructure, you will be able to run the installer and deploy the OpenShift cluster on top of this infrastructure. You can see that for these both options, you can use RHEL CoreOS as an operating system, but in the second option, there is also possibility to run full Red Hat Enterprise Linux as an operating system, but only for worker nodes.
Well, you mentioned this CoreOS. If you could maybe say a few words about it.
Yeah, so the CoreOS is a default operating system for running OpenShift 4, so the latest version of OpenShift. It is based on the Red Hat Enterprise Linux 7, so it is binary compatible with RHEL 8, but it is built in the way that it is dedicated only to run a containerized workloads. So what you have in the operating system is basically the container runtime called CRI-O. So CRI-O is a default container runtime in RHEL 8, and also it's default for OpenShift 4. It's fully compatible with Docker, so you don't have to worry that there will be some issues with running images built using the built-in Docker environment. It also has a kubelet, so that you can connect the server into the Kubernetes cluster. It has the configuration for accessing different container registries, so that you can run container from the images that are stored in different registries, and also it has a SSH for the remote access. The whole operating system is immutable, so it means that you cannot install any custom RPMs or any operating system level libraries. All the custom software that you might run in CoreOS has to be containerized, so you can only run your own containers.
Okay, so maybe a few words about the networking in the OpenShift.
Yeah, so the networking in OpenShift is based on the, it follows the Kubernetes standard. So in Kubernetes, we have CNI, container networking interface, which allows to plug in different CNI plugins, which provide the networking layer to allow the communication between the pods running in Kubernetes. So OpenShift provides out of the box the OpenShift SDN CNI plugin. This plugin is based on the Open vSwitch technology. So it creates a VXLAN overlay network on top of the physical network that connects the nodes within the cluster. Currently, we are also working on the new generation of this SDN plugin called OVN. So it is also based on Open vSwitch. It is just a new generation that opens some new possibilities to implement more sophisticated networking in the future. But still, as of today, the current version OpenShift 4.4, the OpenShift SDN is a default, but you can already use OVN if you want to. And then there is a third plugin which we provide specifically for the OpenStack environments called Courier. And with this plugin, you are able to plug directly into the OpenStack Neutron networking, which is also an SDN. So with that, we want to avoid the double encapsulations of running SDN on top of other SDN. And then there is a number of third-party validated plugins. Currently, you can see on the picture only Calico has passed the certification and validation and is fully supported in OpenShift, but it will be followed soon by other popular SDN or CNI plugins, as you can see on the picture.
Okay, and well, networking is one of the challenges as well with the microservices. Maybe you could say a few words how OpenShift can help us with microservice deployment?
Yeah, so of course the CNI provides the core networking functionality, but for more sophisticated networking application architecture, especially when you build a microservices architectures or other kind of distributed systems where you have many independent services that needs to communicate each other. For that purposes, we also support. We have also created a service mesh, which is also part of OpenShift. The service mesh is based on the Istio project, so the current version of service mesh is based on Istio 1.4. And for the data plane, we are using Envoy proxy. So each service which we want to be managed or included in the mesh needs to run Envoy proxy sidecar container, and all the communication between the services is executed through this Envoy proxy. And all the communication, configuration, security, traffic management, monitoring, everything is done based on the global configuration that is managed by the Istio control plane.
Okay, so maybe a few words about this storage in that case.
Yeah, so the storage is other important topic. So, and it's quite complicated because on the one hand, there are different storage types. So we have at least three major storage types. So we have the file, block, and object storage. On the other hand, storage technologies provide different access modes. So they the most common access mode is called read write once, which means that you can mount storage volume only to the one OpenShift cluster node, and this configuration will limit ability to scale pods that are consuming the storage, because if the volume is mounted only to one pod, to one node, also all the pods could be deployed just on the on this one node. On the other hand, we have read-write many storage technology, so access mode. So with that, in that mode, you can mount a single volume into multiple nodes, and this means that also you will be able to scale your pods across those nodes. So the OpenShift, in order to meet to integrate with different storage technology, provides the integration with or support for many different storage plugins. So depending on the technology and the infrastructure you are running, we support the public cloud storage technologies. We support some on-premise storage technology. Also, there is a large there is also a development of the standard that has been defined in Kubernetes for accessing the different storages, called container storage interface. So there is also a lot of currently development of different plugins that are compatible with that interface. In order to really give you the largest possible flexibility in terms of the storage types you might use, and also in terms of the storage access modes, we also offer OpenShift container storage technology, which is based on the Ceph software-defined storage. With container storage, we have fully containerized Ceph, so you can deploy this storage as part of your OpenShift cluster. Typically, you will choose a dedicated storage nodes where this storage will be deployed, and it is, from the operations management monitoring point of view, it is fully integrated with OpenShift, so you will use the same tools to monitor and manage your OpenShift cluster and the storage cluster, and everything is fully containerized and deployed in OpenShift.
Okay, so maybe other topic, like how do I monitor metrics, some logs in the OpenShift?
Yeah, so in OpenShift, by default, you have built-in cluster monitoring, which is based on the Prometheus Alert Manager and the Grafana. So when you install our OpenShift cluster, you have out-of-the-box installed monitoring and fully configured monitoring for your cluster. So you don't have to install that stack yourself, but also you can extend the configuration of the monitoring stack to be able to monitor your own applications. So it's a built-in feature that you can simply use without need to configure and manage it separately. Then also there is you can also install a log aggregation stack based on Elasticsearch, Fluentd, and Kibana. Currently, this logging stack do not install automatically, but you can very easily install it using the built-in operators. What is quite important here is that from the identity access management point of view, it is fully integrated with the airbag model and the permissions that are assigned to the users on the project's level. So only the user who has the permissions on the project level can access logs from the specific project. And also it is possible to use the stack to export or to forward securely the logs to the external log aggregation components like Elasticsearch, Splunk, or Syslog.
Okay, so how maybe I can limit the resources used by my applications?
Yeah, so this is very important because when you create an application, you deploy some containers. If you don't define some limits on the project level or on for the specific user or tenant, theoretically the application consumes all the resources that your application that your cluster has, which might lead you into the situation where some services will be unavailable. So for that, you have in OpenShift you have two layers for creating the quotas and limits. So the first layer is the project scope. So for each project you can define some default quotas and limits, but also you can define so-called cluster quotas, where you can create a quotas that will be assigned to multiple projects, and you might vary. You have a lot of flexibility in defining the logic behind the decision which projects will be assigned to the specific quota. So here on the screen we have an example of cluster quota that is assigned to the specific user. So every project created by the user will be managed by the single cluster quota. So you can have these two layers of quotas. And also in OpenShift we have a concept of project template, where you can define some default quotas and limits that will be assigned automatically to every project that will be created in the cluster.
Okay, so maybe a few words about the security in general.
Yeah, so the security is a very, very important subject in OpenShift. So we are implementing the defense in depth security strategy. So it means that we are securing every single layer of OpenShift platform. So starting from the operating system, where we have all the security features like SLLinux, control groups or CComp fully configured. Then we have also possibility to define the roles and permissions for not only for the users, but also we can define some permissions for every single container that is executed in a cluster. We can define what system level, operating system level permissions will be assigned to every single container. Then also we can define role-based access control for the users. We can secure the network with network policies. We have fully integrated airbag with all the OpenShift components that are accessed by the user. So the log aggregation, monitoring stack, the web console, the command line. So airbag is enforced on every single layer. And also we provide the fully integrated secret management. So the secrets which can hold some sensitive data are encrypted at rest, on transit. So you have fully secured secret management built in. So in essence, security in depth is a strategy that has been implemented in OpenShift. So we secure every single layer of the platform.
Okay, so and are there any OpenShift related news related to the recent virtual summit too?
Yeah, so we had 2 weeks ago, we had for the first time the virtual Red Hat Summit. So the annual largest Red Hat conference this year has been delivered fully virtual with fully virtual experience. And there were two significant announcements related to OpenShift. So the first one is the first announcement was about the new component called Red Hat Advanced Cluster Management for Kubernetes, which is basically a multi-cluster management solution for OpenShift, and in general also for Kubernetes environment that could be deployed either on-premise or in the cloud. So this product covers offers three major functionalities. So first one is the operational management for multi-clusters. So this means that you can, using the tool, install OpenShift clusters. You can connect, register existing clusters. You can upgrade the clusters and monitor the clusters in general. The second one is the security and compliance functionality, which allows you to define some security policies that will be enforced across all the clusters that you have deployed in your environment. So, for example, you can define a policy that will enforce creation of limits and quotas for every single project in every cluster that is managed by a platform. And the third one is the advanced application deployment functionality across multiple clusters. So it means that you can import your existing applications, which could be either Helm chart based or operator based or simply a bunch of YAML files, and then using the central console, you can deploy your applications in control fashion to the clusters wherever you want to, and the same for upgrades, of course.
Okay, so maybe what about the legacy applications, so that run in regular virtual machines? So can OpenShift help somehow in that matter?
Yeah, so this is the second announcement that has been made. So we have announced a new component of OpenShift called the OpenShift Virtualization, and with that component you are able to run virtual machines based on the KVM technology directly in OpenShift clusters. So what you will have to do here, there is an operator that you can leverage to install this functionality to your cluster, and then you are able to run and deploy virtual machines pretty much the same way like you deploy the containers.
Okay, so maybe let's do some demo.
Yeah, so I will try to make a kind of quick tour with focus more on the platform administrator. So what you can see here, this is a OpenShift 4 console. The overview panel is where you have aggregated view over basically what is going on in your cluster. So you can see here some alerts about some containers that are not working well. You can see here some statistics, some metrics. You can also see the events that are taking place in your cluster. From here you can easily drill down, so you can see, for example, what pods are not running. So you can see the pods. You can then drill down even further to go into the pods, see the logs, see some events. So it's quite easy to drill down to the cause of the issue. There is a built-in dashboard. So in version 4.4, the dashboards has been moved from external Grafana directly into the web console. So you can see a lot of built-in dashboards here, where you can analyze different metrics for your whole cluster, or you can again drill down into some specific namespaces or other components. So a lot of useful information you can find here, a lot of metrics related to different aspects of the project. If you install a log aggregation, you will also have access to Kibana dashboard, where you can quickly get and see the logs that are aggregated in the platform. You can see here the index definition, which as you can see consists a lot of useful metadata related to describing the source of the log. So for every single log message or the line from the log, you see how many additional metadata is added. You can also monitor specific nodes. So if you can see the list of nodes in your cluster here. So here you can see I have 3 master nodes, 3 worker nodes. I can then go to the nodes. I can see metrics for nodes, see what pods are running on the specific node. So it's very very easy to find this kind of information. Then we can see the cluster configuration. So maybe let's slightly switch the topic. So as I mentioned, the whole cluster configuration is operator based. So you can see here there are like 30 operators and most of them, so I think 27 or something, are the core operators that are installed in every cluster, and then you can install some additional on top. So for every operator, there is as I mentioned, there is a CRD file which allows you to configure specific operator, and you follow the same approach for the core OpenShift operator. So you can see here the CRDs for the built-in operators. So we can, for example, go into the configuration of OAuth operator, which is responsible for managing the identity providers, which allows you to authenticate users into the OpenShift based on credentials stored in different identity management systems. So I can here, for example, start to configure a LDAP identity provider, and once I will configure it, the users who are registered in this LDAP will be able to log in. Also from here, as a cluster operator, we have access to Operator Hub, where you can find the operators that are interesting for you or you want to install into your cluster, and you can install them if you want to. So you can choose any operator from the list, and just using this wizard you can install the operator, and then the application developers will be able to deploy some applications that are provided by the developers. So I have also access. You can see what operators are installed. So I mentioned the virtual machine. So you can see that after you install the container native virtualization operator, like you can see here, you will have also additional menu items for running virtual machines. So this is how you can this is the interface. So you can create here a new virtual machine, either using the interactive wizard or based on the YAM file. So for example, I can select the template of the here in the example RHEL machine, and then I can deploy a new virtual machine. Of course, I need to provide name, but I will skip it for now. Yes. So and if you once you create a virtual machine, you can also run it. So you can start the machine. You have access to the console, and here, once the virtual machine will start booting up, you will see the console. So the storage for virtual machines is also is based on the per system volume. So here you can see the per system volumes I have from which I can boot the machine. Also, it is possible that you create some specific container images that holds the image for the virtual machine. Okay, so the other thing here which is very interesting is the concept of machine sets. So you can define kind of templates for the machines that you want to deploy to OpenShift. So for the nodes of your cluster. So here you can see I have three different templates for workers that could be deployed in three different availability zones in AWS, because this is where this cluster is deployed. And you can see here that using the machine sets, I can very easily scale up my cluster. So I can set here how many new virtual machine, how many worker nodes I want to get deployed, and they will be automatically deployed using the this template. Also, there is a concept of auto scaling for your cluster nodes. So it's similar to auto scaling of pods. So you need to define the YAML file where you specify the metric that will be monitored, and based on the metric, the cluster could be scaled automatically up or down. Also, there is a way how you can manage in the centralized way the configuration of your cluster node. So you can see here there is I have two configuration templates which are called machine config pools. If we go here to the worker configuration, you can see here it consists of like 5 different configurations which are holding the configuration files for the components of the worker node. So you can see here, for example, the configuration for the container runtimes, so the cryo container runtimes. So we can then go even further, see the YAML file, and here you can see that the configuration files are encrypted. It is just a regular URL encryption. So if you would decrypt that, you would see the regular file. So in this, it is a registries conf file, so the file that holds the registries that are registered for the runtime. Here is the cryo.conf, so the file that holds the configuration for the runtime itself. So that way also you can, in the centralized fashion, reconfigure your nodes, and these changes will be applied automatically into your worker nodes. And maybe another feature is user management. So again, from the web console, you can very easily manage the users, groups. So you can define the groups, or you can import groups from the external systems, like from external LDAP server. And then you can also create and manage the roles, either project roles or cluster roles, and you can also manage the bindings. So you can grant some roles into the users or groups. So we can, for example, have a look on the user we have here, and you can see that this specific user has the admin role in the project here in the namespace, and also he has some cluster role that gives him access to the monitoring stack. And maybe the last thing, the upgrades. So the upgrades in OpenShift are also fully automated. So once there will be a new version available, so we have now 4.4.3. If there will be a new version, it will be pushed into the channel. So you can subscribe your cluster to one of the channels, depending on whether your cluster you want to have updates faster, or but with bigger risk that there will be some issues, or slower and but more stable. You can subscribe to one of the channels, and when the new version will be released to the channel, you will see here a button that there is a upgrade ready, and you click the button, and this will execute the rolling upgrade of your cluster. So again, very automated and simplified management of your cluster.
And I guess that's everything for now. So stay tuned, I guess. Have a nice day.